See again, 11th question, it's a bacha question they have given. Almost all the questions are straightforward, only the basic levels they have tried to test. Question paper is not that much difficult when compared to the previous years. Such a simple question they have asked that we will not be expecting such a low level questions they will be giving. Again, 21st question, it's a low level question they have given. Why they have given this kind of easy questions, even I don't know. So your score should be 25 out of 25. Hello friends, in this video we shall discuss with respect to the previous year question paper of electronic science paper, which was conducted by NTA UGC NET on 25th June 2025. Paper 2 consisted of 100 questions, which was for 200 marks. In this part 1 video, I am going to cover from question number 1 to question number 25. Let us move on to the first question. In the first question, what they have given is, which of the following statements are true? Frequency of the output waveform of a full wave bridge rectifier is twice when compared to its input waveform. This statement is correct. In the case of full wave bridge rectifier and in the case of bridge rectifier, the output frequency will be twice the input frequency. The frequency of the output waveform of a half wave rectifier is twice they are asking. This statement is wrong. The output frequency should be the same. The output frequency should be the same. In the third option, what they are given is the frequency of the output waveform of a full wave bridge rectifier is the same they are telling, so it is wrong. The fourth option, they are speaking with respect to half wave rectifier, that too the frequency is same, is correct. The DC level of an output of the half wave rectifier is same as, it will not be same. So the corresponding statements A and D is going to follow, nothing but which option it is going to follow? Option 4. In the second question, what they are given is a sinc of lambda power spectral density is independent of operating frequency, MRA-PAM Huffman code. What it requires? We know that the white noise corresponds to, the noise level will be the same irrespective of frequency. N0 by 2 is the amplitude, which is fixed. It's spectral. So power spectral density is independent of operating frequency. B, it is for 1. Which option? Option 3 is going to follow. Sinc of lambda will be equals to sinc of pi lambda whole divided by pi lambda. Then MRA-PAM corresponds to 1 baud, which is equals to log m to the base 2 bits per second. If I am writing base as base 10, base as base E, in case of information theory and coding, I have explained you properly. You please go through the things. And in the case of Huffman coding, the probabilistic model is required. Nothing but how we are going to assign the probability to a code. Important. So for the second question, the corresponding option that's going to follow is option 3 is correct. In the third question, what they have given is a flash A to D converter, successive approximation A to D converter, dual slope and sigma delta A to D. All these 4 A to D converters we have studied. In the case of flash A to D converter, it is the fastest A to D converter. The comparators that is required is 2 power n minus 1, 2 power n minus 1 comparators are required. And what is the execution time? It will be taking only 1 clock cycle. So it is the fastest A to D converter. So for A it is 4, you will be getting the answer. In the case of successive approximation register type, or in the case of successive approximation A to D, what I told, the conversion time is independent of the input what you are going to apply. Irrespective of the input what you are going to apply, the conversion time is fixed, and it is most used A to D converter. And the dual slope A to D converter is the slowest one. It is used in voltmeter measurement, and it is used to suppress the hum effect. Right? And it is the slowest A to D converter that is available. Dual slope or integrating type. And this one, sigma delta A to D converter is 1 bit quantization. So the corresponding option that is going to follow is option 4 is correct. I have made a detailed video on A to D and D to A converter. In just 10 to 12 minutes, I have finished the entire syllabus. You please watch it. I'll be giving the link in the description, or else you can click on the I button. Fourth question what they have given is, consider a plane wave propagating in x direction. The velocity of propagation of a free space is given by, you can consider Vp. Vp is given by 1 divided by under root of mu naught times of epsilon naught. Strictly speaking, V is given by 1 divided by under root of mu epsilon. You will be getting mu naught mu r epsilon naught epsilon r. You are going to take mu r equals to 1 and epsilon r equals to 1, such that you will be getting first option as the correct one. So for the question number 4, option 1 is correct. Question number 5, you see, for the Bode plot of a system to be stable, the phase margin and gain margin should be positive. Yes, phase margin and gain margin should be negative. They are telling it is wrong. Stability of the system is independent of gain margin and phase margin. And stability of the system is dependent on gain margin and phase margin. So corresponding statements A and D is correct. A and D is correct means which option it is going to follow? Option 3 is correct. Look at the things in this series of questions. Almost all the questions are straightforward. Only the basic levels they are tried to test. Question paper is not that much difficult when compared to the previous years. Characteristic equation Z naught equals to under root of R plus J omega L divided by G plus J omega C is correct. Beta equals to omega into under root of LC. This equation is also correct. Now, characteristic equation, this equation is also correct. Vp equals to 1 divided by root LC. This equation is also correct. Right? Now, look at the things. Which and all the statements it is going to follow? Sorry, C statement will be wrong because L should be there, right? Sorry. A, B, E is going to follow. Nothing but option 3 is correct. A, B, E is going to follow. Nothing but option 3 is correct. If you are thorough with the transmission line, minor adjustment you are going to do in the case of waveguides. Or say suppose you are very much thorough in the case of waveguides, minor conversions you require in order to solve transmission line problems. That's it. The conversion table, if you are knowing, that will be more than sufficient. Let us move on to the 7th question. See, Maxwell's inductance capacitance bridge is used for inductance measurement. A sharing bridge is used for capacitance measurement. Frequency can be measured with the help of, we know that we can able to measure with the help of oscillator circuits. Wein bridge oscillator, crystal oscillator, Hartley oscillator and RC coupled oscillator. F equals to, what will be the relation you are going to get? F equals to 1 divided by 2 pi into under root of R1 C1 R2 C2. This is the relation what we have to know. See, the frequency can be measured with the help of Wein bridge oscillator. And in the case of Wein bridge circuit only, you will be having both the feedbacks, both positive feedback will be there and negative feedback will be there. Important. In question number 8, we have to hunt for the correct statements. A PNPN semiconductor. Yes, a thyristor is a PNPN semiconductor. It will be having 4 layers, 3 terminals and 3 junctions. Right? So, it will be having 3 junctions it seems. Yes, J1, J3 will be forward biased, J2 will be in forward blocking state. If you are applying positive voltage at the cathode, this will be the condition. Third statement what they have given is, when anode is positive with respect to cathode, it will be in forward blocking mode. Yes. If it is very much high, then it will be in a forward state. If not, it will be in a forward blocking state. Yes, this statement is also correct. When cathode is positive when compared to anode with the switch open, it is in reverse blocking mode. Yes. When cathode is positive with respect to anode in a forward blocking mode. See, third option and fifth option and fourth option is a little bit tricky. You please go through it carefully. When cathode is positive when compared to anode in a forward blocking mode, it seems E statement is wrong. So the corresponding option that is going to follow is option 4 is correct. Option 4 is correct. You please go through my lecture of thyristor. I'll be giving the video link in the description. You please go through once. Question number 9 is with respect to microprocessor. What they are telling is instruction AAA is used for ASCII adjustment after addition. See, this instruction plays a prominent role only when you are writing after add instruction. Nothing but after executing this add or add-C, then if you are writing AAA, it will be having an effect. Say suppose if I am performing jump operation and then later if I am writing this instruction will not be having any role. So it is adjust ASCII after addition. Adjust ASCII after addition. So this addition is important. All addition arithmetic operations, yes, this operation is also good, but it is going to adjust it, right? So for the question number 9, the corresponding option that is going to follow is option 2 is correct. In question number 10, see, this question is not difficult. This question is dead easy. We know that in the case of Stokes theorem, it is going to convert a line integral to surface integral. In the case of divergence theorem, it is going to convert, or it is going to talk about surface integral to volume integral. Gauss law Q equals to this integral. Anyway, Poisson's equation, we know that del square V, which is equals to minus rho V divided by epsilon. In the case of Laplace equation, del square V, which is equals to 0. This is for Laplace equation. So for this, the corresponding option that is going to follow is option 4 is correct. Poisson's equation, del square V, which is equals to rho V divided by epsilon with negative sign. If you are knowing, you will be in a position to solve this one. Or divergence theorem and Stokes theorem. Divergence theorem, it is going to speak with respect to surface integral to volume integral. Stokes theorem, line integral to surface integral. First you will be getting Stokes theorem, then divergence theorem. So Stokes means a line integral to surface. Surface to volume will be divergence theorem. That's it. So if you can able to remember like this, you would have solved this question. For the 10th question, option 1 is going to follow. See, again 11th question, it's a bacha question they have given. Microcontroller, it is 8051. We know that in the case of 8086, it is going to support pipelining 6 byte instruction queue we will be having. So for A it will be 4 and for B it is 1. You will be getting the answer. See, such a simple question they have asked this time. DMA controller, it is 8257, and the programmable interrupt controller, we know that it is 8259. Remember this carefully. So for the 11th question, the corresponding option that is going to follow is option 3 is correct. 12th question, you see, 8051 is a 8-bit microcontroller. Yes. 8051, it will be having overflow flag. Yes. See, if I am writing the flag register content, you will be having the carry flag, then you will be having auxiliary carry, then you will be having F0 bit, then you will be having RS1 and RS0, which is used for bank selection, then you will be having the overflow flag, then unused, then the parity flag. This is 0th bit, or if you are considering this one as first bit, this will be 8th bit. So this will be 0th bit means this one will be 7th bit. So totally it will be 8 bit, right? Program status word. So it will be having an overflow flag. It will be having the overflow flag. Yes, it will be having an overflow flag. CJNE is an instruction in 8051. Yes, compare jump if not equal. This is being included. So we know that ABE will be correct. ABE will be correct. Definitely 8051 will be having only 5 interrupts. Yes, 8051 has a indexed addressing mode. Yes, it will be having indexed addressing mode. So the corresponding option that's going to follow is option 3 is correct. Option 3 is correct. 13th question, you see, which of the following materials will form p-type semiconductor on doping intrinsic semiconductor? Which is going to form a p-type, they are telling. See, arsenic and phosphorus, these will follow. or this will fall on N type. Or if you are doping an intrinsic with this material, you will be getting N type semiconductor. But if you are doping with the indium, gallium, boron, you will be getting P type. This germanium is belonging to fourth group, silicon and germanium. So this will be fourth group element, right? So the corresponding option that is going to follow is option 3 is correct, nothing but boron. Simple question. So this question, if you are thinking it is difficult, no, it is not difficult. Look at the things. In the case of demultiplexer, how many inputs you will be having? Only one inputs you will be having, but what will be the number of outputs? 2 power n outputs. What will be the select line? There will be an n select lines. Look at the things carefully. At the output end, you are in need of how many outputs? At the output end, you are in need of how many outputs? You are in need of 256 outputs. So each and every demultiplexer will be having 4 outputs and 1 input. So previous stage you will be having one demultiplexer which will be controlling 4 demultiplexers. So here in the final stage you are in need of 64 demultiplexer. Just to previous stage, how many you are in need? 64 divided by 4. Why 4? 4 it will be controlling. So 16 is required in the previous state. That to previous state, how many you are in need? 16 divided by 4 will be 4. Just to that one, how many you are in need? Only 1 is enough. So when you try to add all the things, you will be getting 85. You will be getting 85. So the corresponding option that is going to follow is option 4 is correct. I have made a detailed video on this multiplexers and demultiplexers. I have taught you. Go through my playlist Mission NET. In that digital electronics videos, you try to watch it. I have explained you thoroughly. 15th question. See, this question is also again a simple one. Superposition theorem, we know that it is a linearity. Rutherford's criteria talk about absolute stability. Relative stability, the best one is root locus. Open circuit impedance will be Z parameter, short circuit parameter will be Y parameter. That's it. So for D it is 4. For D it is 4. For C it is 1. For C it is 1. So for B, Rutherford's criteria, we know that it is stability. Such a simple low level question they have asked. If we are making this one as a mistake, no, definitely we will be out of race. So for 15th question, option 2 is going to follow. 16th question, maximum power will be delivered to a impedance if the impedance Z is, strictly speaking, complex conjugate of the impedance Z of the network. Same as the impedance, C says, suppose a load you will be having 5 plus J3. What will be the source? So source should be 5 minus J3. If the load is 10 ohm, let us assume source should be 10 ohm. So which option it is going to be valid means the fourth option is valid. Complex conjugate. Option 4 is correct. Don't opt for option 3. 17th question. Which of the following statements are correct for an N-channel FET? N-channel FET has larger electron mobility when compared to P-channel FET. Yes. N-channel FET has electrons as a charge carrier. Yes, this statement is also correct. N-channel FET is having more noise when compared to P-channel. No. N-channel FET has a larger transconductance than P-channel FET. This statement is correct. So for this, the corresponding option that is going to follow is ABD, nothing but option 2 is going to follow. 18th question is a little bit tricky. You please go through once. CMOS logic, we know that it will be having the least static power dissipation. What will be the dynamic power dissipation equation? You should be very much familiar. You please go through once. In the case of CMOS logic, it will be having a least power dissipation. So it will be having a least power dissipation. In the case of pseudo NMOS logic, it will be having the highest package density because entire the pull-up network you are going to replace by a single NMOS transistor where you are going to prefer depletion mode 1. So for D it should be 1. So for D it should be 1. In the case of TTL logic, strictly speaking, it should be having the highest speed of operation, but ECL logic will be having the highest speed of operation when compared to all others, right? And in the case of TTL logic, you will be having multiple emitter transistors are used. This is correct. So for this 18th question, the corresponding option that is going to follow is option 2 is correct. Straight away simple questions only they have given. Now this one, when I was explaining the VLSI concept, example what I told is 8086 microprocessor, 20,000 to 1 lakh or 20,000 to 2 lakh you consider. So the transistor count in the case of 8086 microprocessor is a 29,000. Such a simple question they have asked that we will not be expecting. Such a low level questions they will be giving. For this 19th question, option 3 is going to follow. 20th question, you see, MOSFETs is a current control device, it seems. No, it is a voltage control device. BJT is a current control device, so it is wrong. BJTs are negative temperature coefficients and MOSFETs have positive temperature coefficient. Again, 21st question, it's a low level question they have given. Why they have given this kind of easy questions, even I don't know. The condition for symmetry obtained for Z parameters will be what? Z11 equals to Z22. This is for symmetry. And for reciprocal, what is the condition? Z12 should be equals to Z21. 99.9999% of the students will be making this question as correct only. So for this 21st question, option 1 is going to follow. 22nd question, you see, they are asking us to arrange in decreasing order. They are asking us to arrange in a decreasing order with respect to noise margin. We know that the CMOS will be having the highest noise margin. So you will be getting the answer. See, again, it's a low level question. This kind of idiotic questions nobody should ask. With one line, you will be getting the answer, right? So this question paper is a dead easy. Question number 22, option 3 is going to follow. In question number 23, what they are given is, what is the unit of electric flux density? D equals to epsilon E. D equals to epsilon times of E. And E is equal to volt per meter. So D equals to, it is Weber per meter square. So for D, the unit will be Weber per meter square. 24th question, you see, what will be the expression for Y? On the top side, if I am taking, it is A into B bar. On the bottom, it is A bar B. You need to add it. What you are going to get? AB bar plus A bar B. Many persons, what they will be thinking is, okay, one more whole complement you will be having. No, you will not be getting that whole complement. Whole complement when you will be getting is when you are realizing in pull-up network and pull-down network. In a logic families, say suppose in CMOS, NMOS, pseudo NMOS, clockwork square MOS. In that one, if you are realizing, you will be getting the complement. But this is a pass transistor logic. Here you will not be getting any sort of complements. So the output what you are going to get is A XOR with B. Option 3 is going to follow. So friends, we have landed on 25th question. Till here, if you have not liked the video, please give it a big thumbs up. Also share this video with your friends. List 1 with the list 2. Matching we have to do. See, damping coefficient they have given delta. In textbooks they are going to give it as zeta. Delta equals to 0 means no any damping. So it is undamped. So for A it is 2. For A it is 2. Delta less than 1 it is underdamped. Delta less than 1 it is underdamped. Okay. Delta equals to 1 it is a critical damped. Delta equals to 1 critical damped. Delta greater than 1 it is over damped. delta greater than 1, it is overdamped. Such a simple question they have asked. We thought that they will be asking the questions from second order system. More questions will be from second order system. But what he is actually testing is whether we are knowing the concepts of delta properly or not. Nothing but zeta, are we in a position to solve? We thought they will be asking peak time, settling time, rise time. These questions they will be asking. No, they have landed up asking all the basic questions. So friends, if you have gone through this 25 questions, all 25 questions are dead easy. So your score should be 25 out of 25. So for this 25th question, the corresponding option that is going to follow is option 4 is correct. So friends, in this part 1 video, I have covered from question number 1 to question number 25. In the part 2 video, I am going to cover from question number 26 to question number 50. If you have followed with the solution video, please give it a big thumbs up. Also share this video with your friends and don't forget to subscribe to my channel Craving Gyan. All the best for exams. Thank you.